Okay, so I'm going to record this. So when you get to the position displacement assignment 1, let's make a copy of it so you can make your own copy. I'm going to call this delete. You guys keep put your name in it. Delete 8 period. I'm recording this so I could put it up in case people miss this or need help with it. Okay, so I got my own copy, delete 8 copy of this. And now we're gonna do number 1, but I'm gonna change the numbers up a little bit so I don't give you guys the answers. But you can copy the process. All right, so then go to whiteboardfox.com and make sure this is working. Actually, I'm just gonna start it over. Whiteboardfox.com. I'm gonna put that in the chat. Or your chat. Chat. There it is. Here's the Whiteboard Fox. So this is a great place to do the problems. Cool. That's not right. So I'm gonna get this. And I'm gonna put it in Whiteboard Fox. Move this over. Okay. So to put text in here, you just go to Options, Add Text, and paste whatever you want in there. So I'm gonna change these numbers. So instead of +10, I'm gonna go. Let's do +9. I'm going to change this to -6. And let's make this -4. All right, so I just made a new problem. So what is your final position? If you start at -4 and make displacements of +9 and -6. All right. So with problems like these with nice whole numbers, it's easy to see it on a number line. So let's do that. Let's draw this in black. I'm going to put 0 here, or origin, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Maybe that's long enough. All right, so next, I would label what are these things. So what is your final position? So we don't know what final position is. Right, we want to know what it is. If you start at -4, so this is going to be xi, and make displacements of 9 meters, d1 and d2. So we've got xi equals -4. We've got a displacement 1 of 9 meters and displacement 2 of -6 meters. All right, so if we just do this on the number line, -4, so 1, 2, 3, 1, 2, 3, 4. So this This is xi. Then it says we're going to move a 9-meter displacement. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, because it was positive, right? Then it says to go back -6. 1, 2, 3, 4, 5, 6. So this is my XF. So what is it? It looks like it's -1. According to the number line. Let's check our work. Let's see if it's true, because we do have the formula xi plus d1, right? Plus, you could have as many displacements as you want. You just have to add them up together. So we're going to plug everything in. So xi was -4 plus 9 minus 6. What does that equal? -4 minus 6 is -10, plus 9 is -1 meter. So there are two ways to do these problems, or think about them anyway. Oops. Where's my chat? Come on, chat. There it is. So there are two ways to think of these problems. One is on a number line, and two, you can use equations. So sometimes some methods are better than others for different types of problems, right? So it's good to have a bunch of different tools so you know what tool to use. So we have the tool of the number line and the tool of the equations. So when you have whole numbers like these, the number line is fine. But if you were to have numbers like numbers like 9.75 and 6.21 as your displacements, an equation is easier to use. You can be more exact. So with this one, we have whole numbers. Are there any questions on this example? Does everybody see where everything came from? All right, well, there's another way to do these. Let's look at the textbook. So first, with this, I would snapshot it. And put this in to our worksheet. So we just did number one, but this is not the answer for number one. This is just an example. Doesn't use the same, I changed the numbers, but this is how you would put it in there. All right. So then let's look at the book. So the book has a little simulation you can play with that can help you with these. So you come to the book and you click on this white button here, and this will open up the simulation. So here it asks you for your initial position. Ours was -4, 9, and -6. So it said -4, and then the displacements were 9 and -6. And so let's look at the simulation. So here he was at -4, he went +9, -6, and he ended up at -1, XF. See, it does it for you. So simulations, computers, they can hold the formulas, and all you have to do is plug them in, but you have to know what you're plugging in and what you're looking for, right? So we were looking for final position, so there it is, -1. Any questions there? All right, so then another thing that they did was they have this here, distance moved. So what is his total distance? Well, he starts by, he starts by going to the right and then to the left. How much total distance did he run? So he goes 9 and then he goes 6. So a total distance of 15, right? So that's what that is. And that's actually the answer to number 2. So here we could just type to get total distance, take, let's say, make all your displacements positive, not COVID-19 positive, just positive. Make all your displacements positive, then add them. So that's going to be, so in this example, we had a 10, no, I'm sorry, a 9 and a 6. So we're just going to add the distance equals 9 plus 6, which is equal to 15. So that's for my example. That's not the right answer. Any questions there, guys? Let's see. Any questions at all? Just movements on a number line. Let's see. So what else can we talk about here? Let's see. clear. All right. This is an interesting one. Let's do this one on the whiteboard. Of course, we'll change the numbers. All right, this is the last one we'll do, and then you guys can work on your own. Oh, I meant to change the numbers. Let's change it to 13 and 5. So let's look at this on a number line. What is this? Oh, nice. All right. So I'm gonna put 0 here. Oh, let's turn the ruler off. And then we're gonna put 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then -5, 1, 2, 3, 4, 5. All right, so then it says, what displacement? So we don't know what the displacement is. And we're gonna start a position of 13. So 1, 2, 3, 4, 8, 9, 10, 11, 12, 13. So we're all over here. And it says to a final position of -5. 1, 2, 3, 4, 5. So we know the positions, we just don't know the displacement. So if we look at our formula, so you can look at it two ways. You could plug in the numbers and then solve for D, or you can go the other way. So let's plug in the numbers. XF is -5, XI is 13. So if I want to get D by itself, I subtract 13, and I get a displacement of -18. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And it's negative because it went to the left. So two ways. We did it through the number line, did it through the equation. You could have also, when you start off with the equation like this, let's see. And my time's about up. We can solve for D. We'll get D equals XF minus XI. So we get XF is -5 minus 13 equals -18. So any way you do this, the number should come out the same. See, I did it 3 different ways. I did it by just plugging in the numbers. I did it by rearranging the equation. And then I did it by the number line. So 3 ways to get that. So the answer is -18. But again, I changed the numbers there. Copy the image, and then I'm going to paste it into my work here. See how cool that looks? I think it looks neat. I think it's neat that we can do this all digitally. I love it. All right, guys. Well, that's it for class, right? It's 3:25. So you can get this assignment 1 done. Make sure you get all your stuff done. Any questions at all before you go? I'm gonna stop sharing.